Okay. So, same idea. Identify the x-axis location of each discontinuity. This is a piecewise function now, so there could be a jump. The white packet has a note that says the jumps only occur at the transition points. Transition means when you change from one formula to another for that piecewise function. So we have three formulas here that make up this piecewise function. We change from one formula to another all around the x-coordinate x equal 3. So x equal 3 is the transition point. So if I'm looking to see if there's a jump, I simply need to check what's happening near x equal 3. So I remember this definition right here. Jump occurs if the left-hand limit and the right-hand limit are different. So I'm going to go find the limit as x approaches 3 from the left. And I want to pay extra credit to the whole room. So just ready, you can work together, but raise your hand as soon as you know the limit as x approaches 3 from the left. Well, this isn't new, it's just review. So talk to each other, raise your hand when you have it. Got a few hands. If I say your name, remember to mark down a tally mark. That's one way I practice names, plus you get more extra credit. So we got Isaac, Logan, Landon, Andrew, yeah, we got a bunch now. So let's go, Ryan, what'd you get? So Ryan got 7. So she thought, okay, I'm trying to find out what's happening when x is slightly less than 3. I have 3 different formulas here, but only the top one is to be used for x values that are less than 3. So she thinks of plugging in a number close to 3 squared, that's close to 9. 9 subtract 2 would be very close to 7. So this limit is definitely equal to 7. Show me your hand if you got it right. 2 points, 3 for right. Question, do we need me to talk through it again or talk through it differently or anything? So now I check the right-hand limit. Here's where I would, in your homework, make sure you're writing down the limit notation. They do require that on the written section of the test. Show me your hands, what's that? Let's go, Sam.
It's also really close to 7.
So now we're using this formula, same logic. We also get really close to 7. Raise your hands if you got it. 2 points, 3 for Sam. Question? Awesome. So the right and left limits are matching, so we don't have a jump. Okay, with a piecewise function, you can have, now, this is where you got to keep the idea separate. On the last example, we used this note, number 7, to factor the function and identify a removable discontinuity as being a situation where you have an x-coordinate that causes the y-coordinate to be 0 over 0. With a piecewise function, you can also have a removable, but it's caused differently. It's not caused by these factors that match. So piecewise, we're just going to check. We already know that the left and right limits are actually equal. That means the overall limit in this case is going to equal 7. So we know that the limit as x approaches 3 is 7. What we now need to find is what is the value of the function itself when the x-coordinate is precisely equal to 3. So hands up, who knows that? What's f of 3? Okay, don't ever pay yourself if you're not raising your hand. That's how you tell how we're doing. So let's go, Zarin. 2. So when x is exactly 3, I have to use this formula. So this is 2. And sure enough, the overall limit right here is not matching the value of the function, that's a removable discontinuity. So we have a removable discontinuity at x equal 3. So please show me hands if you got the f of 3 equals 2. 2 points, 3 for Zarin. Question. Awesome. I'll pay the whole room. I can look at this problem and tell you right away there is no vertical asymptote. I don't have to do any computation. I don't have to write anything. I can just look at it and know. If you can tell me how I know, I'll pay you. Show me your hands. I'll pay everyone who knows. How can I just look at that and say no vertical asymptote? Let's try 10.
Because it gives you all of the x values.
2 points. Keep going. Say it.
That is, like, doesn't have any where it can't use but.
No, good answer. 2 points for that. It's not quite right, but no worries. Who else has an idea? Let's go, Zarin.
Is it because there's no like fractions, and so you know that nothing will be 0 on the bottom?
So we've now seen 2 different ways to have a removable discontinuity. Ending up with 0 over 0, or simply identifying this situation, we'll find a removable. However, with vertical asymptote, there's only one way, and that's to end up with an x-coordinate, which will cause the y-coordinate to be a number divided by 0. These are the formulas for finding the y-coordinates. There's no way to pick an x that will make any of those formulas become something divided by 0, because none of those formulas have a denominator. So that's how I know there is no vertical asymptote. You keep hearing me in class keep referring to the fact that all we're doing over and over again is we have a long list of xy pairs, and we're just paying attention to what's happening at different x's. That's all we've done in all the packets we've worked on so far, really. Just looking at what's happening at different x's. You only get a vertical asymptote if there's an x which will cause the y to become number over 0. We can't, that's not going to happen. So 3 for Zarin. Who else had their hand raised and knew that? 2 more points. Okay. Question. Awesome. You can find the limit as x gets close to 3. Well, we've already found that right here. The limit as x approaches 3 from the left is 7. So all I have to do is write it down. Limit as x approaches 3 from the right is also 7. Therefore, the overall limit is 7. And we found the value of the function to be 2. So we're finished. Question. Awesome. Please go forward and stop that recording.